Salutations, and I am here with my Batman mug. I used to be a Superman guy, but now I'm leaning more towards Batman. And uh, we're going to do some partial fraction practice. The the example is from Calculus Made Easy by Sylvanus Thompson. If you're watching this in the replay, I will at some point hopefully get to putting something in the description or in one of the comments so that you can go straight to the parts of interest. But the download, you can download the whole textbook. It's free from Project Gutenberg. It's the text is about 100 years old. He takes a bit of an unconventional approach to calculus, unconventional by today's standards. He doesn't focus so much on limits, which you'll get in modern calculus classes. It's more intuitive. One observation I have is that I think what's happening is he's assuming a certain background. He's assuming a certain background in pre-calc that isn't necessarily common these days. I noticed that with his binomial theorem. So I had to do a whole thing on the binomial theorem. And likewise here, he glosses over, with this example, he glosses over solving a system of linear equations, which I am going to do something that I strongly suspect he would not have done. Christopher from Switzerland, greetings to you as well. Please, also, I want to ask you, if you're listening to this in the live, give me some feedback about how it looks and how it sounds, because I'm trying different things. So, question for you. Yeah, that was totally unintentional. Um, question for you. Can you hear me okay? Or if you can't hear me, so I'll just say, can you hear okay? Okay, you'll see that if you don't hear it. And we'll launch right into it here. I'm going to share the Miro board. Share screen. And let's see here. Chrome tab. There we go. And there's the whole board. You can't even see me, which I think will be okay here, because I want to focus on what you can see here. So what we're looking at here is, let me just bring that up. There we go. Get that full screen. We're looking at this rational expression. 3x squared minus 2x plus 1 all over x cubed minus 3x minus 2. Okay, there's a rational expression that we want to be able to do some calculus to. And in the context of the textbook that we're looking at, we're splitting it into partial fractions to make the derivatives easier. The idea is we process it first and then do a bunch of simpler derivatives rather than differentiate this beast the way that it is. We could probably get away with differentiating this the way that it is, but when we do integration at another point in time, we'll be really glad for this business. So the first thing that we want to do is we want to see if we can simplify this expression further. So we're going to factor it as far as we can get. So let's take a look. Let's take a look at this first bit right here. Can we factor this? And it's a quadratic expression. So we're just going to check the determinant, which is the, if you know the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. We're just going to check this bit right in the middle, okay, the determinant, to just see kind of a factor, not kind of, it's a factorability test. We're going to see what kind of factors we can get. So our b squared, that's going to be negative 2 squared minus 4 times a is 3 and c is 1. And so we end up with 4 minus, that's going to be 12, which equals negative 8. And because we've got a negative sign within this radical, we have no real roots. And depending on your disposition, that's either good news or that's bad news. The good news is there's nothing else we're going to do with this thing up here, up on the top. The internet line is very okay. That might be on. Yeah, I don't know. Maybe that's my end. Let me just check. I'm going to check out how my internet's doing here. Okay. Yeah, we'll see how this turns out when we're on the replay. How it sounds. Okay, so no real roots up here. Okay, so now let's just focus, and I am going to remove all of this, and we'll focus on the denominator. Now, what we have is we've got a cubic. Okay, so we're not going to be using a cubic equation for this, but it doesn't have an x squared term in it, but it's what you call a monic polynomial, which is just a really fancy dancy way of saying that's a 1 there. Okay, so according to the rational root theorem, if there are rational roots, they will be the factors of this baby. So factors will be plus or minus 1 or plus or minus 2. Okay, so we can test for rational roots just by using these factors. All right, and so for example, let's say we want to test for plus 1. Okay, so we'll put in the plus 1 into this, and so we get 1 cubed minus 3 times 1 minus 2, and that's 1 minus 3 minus 2, and the whole point is that's not 0. Okay, so 1 is not a root, and we can check. There's only 4, and we can check them all. Let's check the negative 1. So doing that, we get negative 1 cubed minus 3 times negative 1 minus 2, which is negative 1 minus 3, which is plus 3 minus 2, and that equals 0. So we know that one of our roots is negative 1. And we could go on and check the other 2, but we're going to stop at the negative 1 because that's enough for us to convert it into a quadratic expression. And then once it's in a quadratic form, we've got a lot more ways to break it down. So we're going to go with that. But first, a non-sponsored message from Batman. What's this? I'm just going to go back and check to see if anybody's saying, I can't hear you. Okay. All right, so let's continue to do this. I'm going to scroll. So one of the roots is -1. So that means one of the factors is x minus -1, which equals x plus 1. So that's one of our factors. So let's just use some long division and factor this whole baby. So x plus 1 into x cubed. Now let's be careful here. Let's actually, that's a 3. Let's throw in the x squared so that we've accounted for it, minus 3x minus 2. And let's see. Well, we're going to start up here with an x squared. X squared times x is x cubed. X squared times 1 is x squared. And then factor that, subtract that, long division style, 0 minus 1, end up with minus x squared, and bring down the 3x. All right. Now, deal with that x squared, we need to go with minus x. Let's scroll that a bit here. Minus x times x is minus x squared. Minus x times 1 is minus x. So these two are the same, so those are going to cancel. Okay, so that's beautiful. So we just leave that blank. Now we got to be careful here because we're subtracting and subtracting. So it's minus 3 minus 1. Okay, so that's going to end up being minus 2x. And then we bring down that minus 2. This was just, that canceled. And then now we have minus 2x minus 2. And let's make this a little bit more visible. Let's put a minus 2 up here. So we have minus 2 times x is minus 2x. Minus 2 times 1 is minus 2. Subtract d, and we get 0. So that's perfect. I mean, which is what we expected because we had determined already that x plus 1 was a factor. So now let's kind of summarize what we've got here so far. We've got x plus 1, x squared minus x minus 2. So x plus 1, x squared minus x minus 2. Okay, and that's partially factored denominator. Now we've got one more set of factoring to do, and that's this quadratic. And we've got all sorts of tools. We can do this by inspection, okay? And we end up with x, and then one of those is a 2, and one of them is a 1, and that's going to be minus 2, that's going to be plus 1. And I just doing that by inspection. And then, of course, let's not forget this one here, x plus 1. All right. So now we've completely factored the cubic. All right. So let's go back. So let's rewrite our whole thing here. This is the expression that we want to convert into partial fractions. That's the numerator, which we found we could not factor. And the denominator, we did factor. And we actually found only two different factors because the x plus 1 appeared twice. And then x minus 2 appears down here. So what we have, we've got three factors, or three potential factors on the bottom. This one here is represented x squared. We have to represent each possible power. If that was x plus 1 cubed, then we'd have x plus 1 cubed, x squared, x plus 1. And then over here, we have x minus 2. Okay? And because each factor is linear, these are just going to be constants up here, A, B, and C. Batman. Oh, it's live. Yeah. Hey. Yeah. Oh, it's live. Yes, I'm live. I hope. Okay. So now we've broken it. Now we've broken it up into our, I guess, our skeleton. And I'm just moving around my notes here. So let's focus on convert this into a system of linear equations. This means that 3x squared minus 2x plus 1 is going to equal a times whatever else we need down here so that we can have the common denominator be the entire cubic. And what's missing here? It's just the x minus 2. Okay. Plus b, what do we need to multiply all this by to get the full denominator? Well, we need an x plus 1. And we need an x minus 2. And then plus c, we need, well, we've got the x minus 2, we're missing the x plus 1 squared. X plus 1 all squared, all right? And let's expand these so that we can get a clearer picture of what we're doing here. So this is all going to equals a x minus 2 plus b. What did that work out to? That was x squared minus x minus 2. And then c is x squared plus 2x plus 1. Just expanding what we've got here. I am not online every day. I'm online when I'm able to, and sometimes I have to surprise people. Today I was able to make plans ahead of time, so I did that. If you want me to be online every day, send me a smile emoji or something like that to encourage me, but I don't know if I can do it. I like it. I like doing online. All right, so what do we need to work out here? We need to work out some sort of equation for A, B, and C. So let's go back up here because we really want to be able to see this. 3x squared minus 2x plus 1. So first of all, let's find out an expression for that 3. Okay, so the 3 is going to be whatever coefficients we have for x squared. And the good news is we don't need to multiply all this out. Let's just look. This a isn't going to have an x squared. Okay, this b is going to have an x squared. Okay, the coefficient here is 1, and the coefficient here for if we were to multiply all this, we'd have the coefficient of 1 that we'd have to deal with. So we've got b plus c. That gives us our x squared coefficient, which is 3. Okay. And then now let's go to, now we need our x coefficient, which is going to be minus 2. So let me just write that down here. It's going to end up being minus 2. And so what's our x coefficient? Oh, well, we got an a, okay, because a times x. So we've got an a. We're going to have a minus b, and then plus c times 2. So it's going to be plus 2c. Okay, and then finally, we need our constant term, okay, which is going to involve everybody. So let's see, we've got, so the constant is going to end up being 1, right? So we've got minus 2a minus b. Oh, sorry, that's minus b. Why do I have minus 2b? Oh, because I'm looking at the x. Sorry. Yeah. So minus 2a minus 2b, and then minus c, and that equals 1. Okay. And now here's where I'm going to take an angle in the textbook, Calculus Made Easy. Thompson just says, and then we solve this system of equations. And I am not going to focus on that solution, but I'm going to do something that I bet you he never would have done. I'm going to write this as a matrix. Okay. So what do we've got here? I'm gonna write this. I'm gonna write 0a, and that's a 1, and that's a 1, plus 1, and these, you know, that's a 1, and that's a 1. And I'm gonna write this as a matrix: 0, 1, 1, 1, negative 1, 2, negative 2, negative 2, negative 1, and we'll make that an augmented matrix with 3, negative 2, 1. And you may not have expected some linear algebra here, so we're not going to dive right into it. But this, if you're not familiar with this, this is a way of solving a system of linear equations in which we take out all of the fluff and we just organize it in terms of what we call it a coefficient matrix. Okay, it got all the same information, okay, but without the A's, B's, and C's. Okay, and then now, if you do linear algebra, you'll learn how to manipulate these matrices so that you can end up with a solution to this system of linear equations. Okay, but the thing is, if you end up using linear algebra, you end up doing these huge matrices. And the good news is it's an algorithm which a computer can do. So yes, that's what I'm going to do. Oh, probabilities, math. Yeah, I can do some probabilities. Done a little bit of that. Hang on here. So I'm gonna bring up. Hang on here. Oh, it's me. I'm gonna bring up something. Chrome tab, and there it is. Solving systems of linear equations, and I will put a link to this matrix calculator. Again, down in the description or one of the comments or something like that, I'll pin a comment and we'll put a link to that. It's matrixcalc.org. And we've got here, I've gone to where it says solving systems of linear equations. And I've just plugged in my matrix. So on the left-hand side here, I've got the 0, 1, 1. 1, -1 and 2, and -2, -2 and 1. And on the right hand side, I've got 3, -2, 1. We've got the values of each of those equations. And all I did was click on solve. Solve by Gaussian elimination. It gives you the whole process if you're interested in that. But here, there's our solutions. So this -2, that's our A. The 2 is our B, and the 1 is our C. So that's maybe a little bit of a cheat, but I didn't want to go into that whole process of solving the equation. And so you might say, well, I mean, I could have just gone to Wolfram Alpha and plugged in. I could have just gone into Wolfram Alpha, and plugged in and plugged in, do the whole partial fractions, and it would have done that. So maybe going in and doing computers is a bit of a cheat, but I think it's an important part for mathematical literacy to know, like, math Avengers, like you said, I didn't know we could do that. There's all sorts of ways of doing different things. And something I see a lot of these days that I'm just not even familiar with. I have to relearn it every time I have to teach it. is this synthetic division, in which we take one of the factors, and I mean, I did a long division. To me, that just comes naturally. Okay, that's just natural. Synthetic division is very similar to this these matrices where you just put in the meat. You just put in the numbers and you manipulate them, but it's very computerish, but it's not as intuitive. You can't quite see what's going on. And I realized I kind of did that with that. We could do whole videos on the matrix algebra. But let's go back, because we're just about done. Really, we are just about done here. Unless somebody wants me to go through and actually take the derivatives of these things. But we ended up with, and I'll bring back our whiteboard. Okay, so there you go. You got the whiteboard. All right, cool gang, cool beans. Right. So what did we work out when we did all that? We ended up with. I do that, and then I end up doing this anyway. We end up with A equals -2, B equals 2, and C equals 1. Okay, and that's all we were after, because scrolling back over here, this, and let's just fill it in now, okay? And let's use a different color. So this ends up being -2. B ends up being 2. And for some reason in the textbook, he transposes these and he does them in the other direction. And I thought, what are you trying to do to us? And that ends up being 1. So these are our 3 partial fractions. And they are much easier to manipulate. Does anybody want me to go through and actually find the derivative, or shall we just call it a day? Because that's all we were after, is partial fractions. There's your Bob's your uncle. Oops, I crossed it all out. That's really ugly. BYU. Alrighty. So stop the screen. Thank you for joining the live stream, and we'll see you next time. Will it be tomorrow? I don't know. It'll be next time I'm able to do one. Alrighty. So cheers, people, and thanks for coming out. Bye.